All right, we're going to continue our investigation into the cosine law, and what we looked at in the previous lesson you may want to look at is how to use the cosine law to solve for a side length and an angle. And in this particular first two examples, example 3 and 4, it says try it yourself because we're going to do the exact same thing again. It's just going to be practice on your own, so you might want to pause this video and then play it later on to see if you can get the answer of 13 if you can't, or you can see if you're getting the process right. All right, so this first question, and then we're going to do one extra example after that. This first question says for triangle DEF, which you don't have a diagram for on your particular study guide, side E is 12 centimeters, side D is 9 centimeters, angle F is 75 degrees. Calculate the length of side F to the nearest tenth of a centimeter. So the first thing we want to do is sketch this triangle as accurately as possible. So I'm going to call angle F being 75 degrees, side E, so I'm going to call this side E here, which is 12 centimeters. Which I'll make opposite. Remember, the sides are always opposite their equivalent uppercase angles. And side D is equivalent to 9 centimeters. So here's angle D. So it says determine the length of side F, which is right here, to the nearest tenth of a centimeter. So we've got our triangle drawn as accurately as possible. And as I mentioned, these, your angle and the side you're solving for, need to replace the uppercase and lowercase a in the cosine law all the time. Where the other two go, the 9 centimeters replacing lowercase b or lowercase c, and 12 replacing lowercase c or lowercase b, doesn't matter. So let's go ahead and set this up. So it's going to be f squared is equivalent to 9 squared plus 12 squared minus the product of 2 times 9 times 12 times the cosine of 75 degrees. And my first step, just being careful as far as my order of operations go, I'm just going to evaluate the right-hand side, is to do 9 squared, which is 81, 12 squared, which is 144, and then I'll find out this product here. And again, make sure you're in degree mode. And the product of 2 times 9 times 12 times the cosine of 75 is equivalent to 55.9 approximately. So I'm going to put 55.9 here. The next thing to do in our order of operations or evaluation is to find out the sum that's on the right-hand side. So 81 plus 144, since they're all constant terms, I can just collect them and find out that sum. And I typed in the wrong thing, so again, just be careful that you're typing in the correct values. And I have 169.1. Again, it's not realistic that this side would be 169.1 centimeters when the other two are 9 and 12, because our last step, again, in case you forgot, is to take the square root, because the opposite of squaring is the square root. And if I take the square root of 169.1, I'll have approximately 13, so approximately 13.0 centimeters, and that's my solution. All right, next example is determining the measure of angle B to the nearest degree. So in this particular case, again, since we're solving for angle B, even though this triangle is called ABC as well, so we're solving for triangle B or angle B, its opposite side, which is 8, will be replacing the lowercase a. So you just need to be careful about that. The other two sides, again, 6 and 9, can replace the lowercase b and lowercase c in either order, but it's crucial that the 8 replaces the lowercase a. All right, so if I start substituting, it's going to be 8 squared is equivalent to 6 squared plus 9 squared minus the product of 2 times 6 times 9 times the cosine, and we're solving for angle B. All right, so my first step is going to be finding all of these products. So 8 squared is 64, 6 squared is 36, 9 squared is 81, 2 times 6 times 9 is 108. Cos B. In this particular case, to simplify the right-hand side, I can collect these two like terms. The third term is not like. So the simplest form of the right-hand side, 36 plus 81, is equivalent to 117 minus 108 times cos B. Now we've simplified each side as much as possible. So we have to move into solving. So if I subtract 117, I would have here 64 minus 117. Negative 53. So on the left-hand side, it's negative 53 is equivalent to negative 108 times the cosine of B. And we need to divide. Some are tempted to add 108, but we need to divide by 108 because it's a coefficient. So in this particular case, and I'll find out what this quotient is here. So we have the cosine of B on the right-hand side, and I'm moving it to the left now, is equivalent to negative 53 divided by negative 108. And that is 0.4907407. 0.4907407, etc., etc. And last step is to solve for an angle. We always take the opposite of cos, which is the cos inverse of that particular ratio. And we'll get, as you can see on my calculator here, I'll press second cos because that's the cos inverse of my previous answer or ratio, and hit equals, and I get 60.6 degrees, and to the nearest whole number, that's 61 degrees. And that looks like it's somewhat of a realistic solution. In our last example, it says solve the triangle DEF to the nearest tenth, which is kind of a combination of everything we've been learning so far in this chapter. We need to solve for all of the unknown sides and angles. So in this case, we need to find out what are these two angles here and what's this side length here. In this particular case, we cannot use the sine law initially because in order to use the sine law, you need to know an angle and its opposite side, and we do not know the opposite side of 57 degrees. So we're going to use the sine law here, or the cosine law, I should say, sorry, and we're going to replace, maybe I'll call this lowercase f. We're going to solve for side f first. That's the only way and the only thing we can solve for. So we're going to replace these and these and start solving. So we have f squared. I'm going to do this pretty quickly because this should be a review of the previous things that we've learned. So 2 times 7 times 8 times the cosine of 57 degrees. And again, finding out all of these products. If f squared is equivalent to 49 plus 64 minus, and the product of 2 times 7 times 8 times the cosine of 57, 61 looks like. So f squared is equivalent to 49 plus 64 minus 61, so that's 52. So f is equivalent to the square root of 52, which is roughly 7.2. So that's 7.2 centimeters. So as we find that out, we can replace it in here. Right, moving on from there, in order to solve for one of the remaining angles, maybe I'll start solving for angle E, let's say. I could use the sine law or the cosine law. I'm going to use the sine law just as a review of that, but because we now have an angle on its opposite side, we can use the sine law. So the sine law states, and I'm solving for an angle in this particular case. So the version that I'm going to use would be this one, sine of A over A, because if I'm solving for an angle, the angle goes in the numerator. It's equivalent to sine of B over B. But in this particular case, we're going to put the unknown angle in the numerator of the first fraction. So I'm solving for angle E in this case. So I'm going to rewrite this as sine of angle E over its opposite side, 7, is equivalent to sine of 57 all over its opposite, which is 7.2. And we'll do this pretty quickly here. If you forgot how to do this, you might want to go back and look at the sine law lessons. So this is going to be sine E is equivalent to, and again, find out this side here, being very careful, do it in multiple steps. So sine of 57, hit equals, divide by 7.2. That gives me the proportion, hit equals, times by 7, hit equals, and I get a ratio of 0.81537, 0.81537. So in order to solve for angle E, I would take the opposite of sine, which is sine inverse of 0.81537, etc., etc. So angle E is equivalent to roughly 54.6 I have, because it's a rounded answer. So 54.6 degrees. So this is 54.6 degrees, which then in turn, the last thing I can solve for, and the easiest way to solve for angle D would be sum of angles of a triangle. So angle D, I would just do 180 degrees minus 57 degrees minus 54.6 degrees, and that would give me roughly 68.4 degrees. So I've solved the triangle. So in conclusion, looking at the cosine law in specific, here are the key ideas. The cosine law says for any triangle that side a squared is equivalent to b squared plus c squared minus the product of 2 times b times c times cosine of a. And there's two ways we're allowed to use the sine law. So in order to use the cosine law, you must know one of the following. Either two sides and the contained angle. So if I know these two sides, The contained angle is the one that is between them. So in other words, your contained angle would be this guy here. So those would replace all of these. So that would be if you're solving for, it helps to solve for an unknown side. That's one case. The other case is if you know all three sides. So if you know this side, and this side, what you would do is you would know your A, B, and C, and you'd be solving for an angle. So this helps to solve for an unknown angle.